Okay, guys, we're going to go over the characteristics and the graph of the parent function for tangent. So it says using your unit circle and your knowledge that tan of x is equal to sine of x over cos of x, graph y equals tan of x on the interval negative 2 pi less than x less than or equal to x less than or equal to 2 pi. Then identify the domain, range, asymptotes, period, increasing, decreasing intervals, and if the function is even or odd. All right, so again, let's start with the foundation that we're going to graph the unit circle. One, zero, 0, 1, negative 1, 0, and then 0, negative 1. All right, we know that this is going to be 0 pi over 2 pi 3 pi over 2 and then 2 pi as well. Okay, now another value that we know about tangent, because it's sine over cosine, is at pi over 4, radians, right? We know that tan is equal to 1. All right, and if we were to kind of extend the line by symmetry going into the third quadrant, it would be 1 as well. I just kind of fixed the line. So this would be at 5 pi over 4. We would also have that tangent is 1. And then conversely, in quadrants 2 and 4, at 3 pi over 4 and 7 pi over 4, we know that tangent is equal to negative 1 here. And at these, at x equals, sorry, at 0 radians, right? If we do sine over cosine, so remember sine over cosine, this is y over x. Okay, so the unit circle values, again, and I talked about this before, tan of x is the same as the slope of the radius. And that makes sense when, especially when you look at pi over 4, 5 pi over 4, 3 pi over 4, and 7 pi over 4, right? We have a diagonal slope of 1 in quadrants 1 and 3, and then a diagonal slope of negative 1 in quadrants 2 and 4. And at these values here, at 0 radians, our tan value is going to be 0, because it's 0 over 1. And let's make the table values. X tan of x, which is the same as y over the x value from the unit circle. I'm just going to write from unit circle like that. Okay, so at 0 radians, it's 0 over 1, which is 0. At pi over 2 radians, it's going to be 1 over 0, which is undefined. Pi, same thing, 0 over negative 1, which is still undef. Sorry, which is 0. Sorry. 0 over negative 1 is 0. And let's kind of reiterate the point that it's a slope, right? 0, the slope is 0. At pi over 2, we have a vertical slope. That's why it's undefined. At negative 1, we're back to a slope of 0. At 3 pi over 2, it's going to be negative 1 over 0, which is undefined. And if we look at the slope of the radius at 3 pi over 2, it's vertical. And then finally at 2 pi, we're back to 0. Okay, same as what we had here. All right, so now that we have our table of values, okay, let's and we have our unit circle relationship. Let's go and graph our tangent function. At pi over 2, we know that it's undefined, so there's going to be vertical asymptote there. And at 3 pi over 2, we're also going to have that the function is undefined. Okay. Pi, we're at 0. 2 pi, we're at 0. 0, we're at 0. Okay. And I'm going to plot pi over 4. Let's try to put a little bit more in the middle. Pi over 4. 3 pi over 4 here. 3 pi over 4. 5 pi over 4. 7 pi over 4 here. And we're going to have negative pi over 2, we're going to have an asymptote, and negative 3 pi over 2, we're also going to have an asymptote, like that. Okay? So we know at pi over 4, we're going to be at 1. 3 pi over 4, we're going to be at negative 1. 5 pi over 4, we're going to be at 1. 7 pi over 4, we're going to be at negative 1. And then we're going to be back at 0 here. By symmetry, we're going to be if negative pi over 4, that's the same as 7 pi over 4, so we're going to be at negative 1 there. So looking at the function, it looks like it's going to be like a linear function in between here. But if we were to graph tangent of x in your graphing calculators to just verify what's happening, okay, we'll see, you guys should see, I'll give you guys a minute to do it. So if you need to pause the video now. Now, hopefully you plotted it and you've seen that it'll look like the cubic function in between. It looks more like a cubic function. And it'll look like a cubic function in between here as well. And then from 3 pi over 2 to 2 pi, it'll kind of just look like the, let's say, the lower portion of the cubic function, like that. Okay? And from here, pi, we're at 0, negative pi, we're at 0, negative 2 pi, we're at 0. This is actually going to be the top half of the cubic function, or like let's call the cubic shaped function for a tangent. Hold on, let me clean this up. Okay, that looks better. And then in between here, we're going to have the same cubic function type shape. Okay, so our domain for tangent, okay, it's x is an element of real numbers, except it cannot equal pi over 2 plus n pi. Okay, where our function is undefined, that's actually where we're going to have our vertical asymptotes. X equals pi over 2 plus n pi. And that's illustrated here, right? Pi over 2 is our first asymptote, and then it goes 3 pi over 2. The next one will be at 5 pi over 2. If we subtracted pi from it, we're at negative pi over 2. Subtract another pi, we're at negative 3 pi over 2. So that's what the notation is for the domain. Okay. And what's different about tangent, the big difference here is that one period is actually pi units. Okay. So from negative pi over 2 to pi over 2, it runs the gamut of the values. Pi over 2 to 3 pi over 2, that's just only pi radians, okay, or pi units. So our period for the parent function of tangent is pi. The range is negative infinity to infinity, and that's illustrated in kind of this cubic function shape, right? It's going down to negative infinity and then up to positive infinity in the intervals where it's defined, okay? The tangent function is always increasing, and I'm going to put, again, a note when it's defined. Okay. And then is it an odd or even function? You guys should pretty much tell pretty clearly that it's going to be an odd function because there's symmetry about the origin there, right? So there's odd symmetry. And remember, it's symmetry about the origin in terms of the description. And if we think about it using a set of coordinates, remember what odd symmetry meant was if we had x comma y, then if it was odd, it would be, well, let me rewrite this here. If we had xy, then the odd symmetry would make it negative x, negative y. And our example that I'll use here is pi over 4. We know we have our coordinate is 1, and I'll put it in blue here. Versus if we change the sign of the input, negative pi over 4, it also resulted in the opposite sign for the output, and that's illustrated there. Okay, so these are all the characteristics of the parent function for tangent.